So now we're moving down to the solving inequality section of our notes today. Um, I tried to write them in to save a little time. Pause the video if you need to. There is a bit to write on here. So the process of solving an inequality is the same as solving an equation. Just like everything in math, there's always what seems to be an exception. But if we multiply or divide by a negative, we have to flip the symbol. So if you haven't written this down yet, please pause the video and write it because I am going to erase it. So let me put a couple of examples. You should have plenty of room to write them over here on the side. Before we get into these problems, I just want to show you a couple of examples of why that exception is what it is. So I'm going to put a relatively easy problem. 3 times x is less than 6. And you can write this or not write this. It doesn't matter. Just follow along with what I'm doing. So I'm going to solve my inequality, 3 times x. So I want to get the x by itself, so I'm going to divide. I'm going to do the opposite. That goes away. Just like when we have an equation, I'm going to bring everything down less than 2. So now I'm going to use what I know about number lines. I'm going to graph this on a number line. 2, 3, 4. 1, 2, 3, 4. It's not a very pretty number line, but it'll get the job done. So I'm going to put my circle on 2, and my arrow goes to the right. So what this means here, anything on the arrow is part of the solution, which means our inequality is true. Anything not on the arrow is not part of the solution, which means if we check our work, it would be false. The actual circle is kind of up for debate. If it's not colored in, it's not part of the solution. If it is colored in, it is part of the solution. So let's check our work. I'm going to take my original problem, 3x less than 6. So I'm going to pick a number that's on the arrow. I'm just going to use a 1. So I'm going to substitute that in for x. 3 times x is less than 6. So let's see, true or false? Alligator mouth is biting the 6. Well, that's true. Now, if I picked something on the not solution side, when I plug it in, it would come out as false. Hopefully you remember that part from junior high, just to kind of refreshing our memory. Now, let's go over the exception to the rule. I'm going to do almost the same problem. 3x is less than 6, except this time we're going to put a little negative in front of the 3. So when I get the x by itself, it's negative 3 times x. I'm going to divide by negative 3. So we have x, and then 6 divided by negative 3 is negative 2. So what you have to do here is this symbol flip-flops. And the reason for that is when you are multiplying or dividing by a negative, you're actually flipping to the other side of the number line. You can test out the whole true-false idea without flipping that, but I'm just going to show you now. Come on. Oh my goodness, I guess I'm going to keep the red. It won't let me change colors. So 2, 3, 4, 5, 6. So 0, negative 1, negative 2, 1, 2, 3. So I'm going to put a dot on negative 2. And my arrow is going to the right. Okay, this arrow. So if I check this, negative 3x less than 6, there's my original problem. And I'm just going to plug in a 0 because 0 is easy. That's on our arrow. 0, that's true. Alligator mouth is biting the 6. If I didn't flip my symbol, that would have been false. So the bottom line is When you multiply or divide by a negative number, you have to flip the inequality symbol. That's all there is to it. Make sure before you continue, if you have been copying this down, you write it down. If not, that's okay. We're going to do some problems now. So for these, we don't do any symbol flipping. They're just two-step inequalities now. Here's our alligator mouth. Remember, when you have two steps, you're doing PEMDAS backwards. So you do add or subtract first to move the constant over, the plain number, and then you do multiply or divide to get the letter by itself. So for this one, I'm going to subtract 2 on both sides of my inequality, bring down my 3x, less than, so negative 4 minus 2, when you combine those, you get negative 6. And I'm going to divide by 3. Now, this is one of those things that make algebra seem so tricky. We have an x. I am not flipping the symbol. My negative is up top. That was already over on the right side. I didn't change anything. I divided by a positive number. So x is less than negative 2. And if you're not sure, you can always check your answer and see which one works, see which one is true. So for each of these problems, we are going to graph our answer, our solution on a number line. So I'm going to do 0, 1, 2, 3. Remember, you can start your number line wherever you want, as long as your solution that you found is on your number line. So I'm trying to change color, get out of this pink, but there we go. Negative 2, and the alligator mouth is pointing to the left. So that's our solution. X is less than negative 2. Now for question 10, this one's a little bit trickier. Here's our inequality border. I would say this problem is x divided by 6 plus 2 is greater than negative 1. So remember, the fraction bar just means divide. So I'm going to get rid of my plus sign, minus 2. X divided by 6. So negative 2, or negative 1 minus 2 is negative 3. So remember, the opposite of divide is multiply. So I'm going to multiply this side by a positive 6, multiply this side by a positive 6. X is greater than negative 18. Whew. I didn't flip the symbol because I'm multiplying by a positive 6. So let's see. I'm going to put negative 18 here, negative 17, negative 15. Big numbers are such a pain to plot. Okay. So negative 18, don't color it in because there's no equal to bar, and the arrow points to the right. So from here, I'm going to stop the video. I'll make another one. The next page is just more practice. So what I'll do is the problem and then go through all of the steps.